Hello. Right, we have a talk from Renan from Cloudflare.
Yes.
Thank you. You're going to talk to us about WebRTC and Cloudflare.
Yes, I guess, yes.
Yes, and just ignore everything that Luke just...
Oh,
Just
no,
tell us.
I think my talk is very similar to Luke's. Yeah, and I apologize if everything is
Orange.
orange. I think it's on the Cloudflare theme. Yeah, apparently my video output is very orange for those at home.
And then while I'm up here, I'm going to say thank you to Cloudflare again for
Yes,
sponsoring.
thank you to Cloudflare for sponsoring
for
CommCon.
the space.
Yeah.
Very, very much appreciated. So off you go.
Okay. Yeah, my talk is very, is it really orange? My talk is very similar to Luke's actually, and it's very relevant to, I think, WebRTC, but also kind of MOQ and stuff like that. So a few weeks ago, we launched in open beta a product called Cloudflare Calls. And I'll talk about what it is, but it's basically an SFU, but a service SFU that is kind of a more unique architecture than a lot of different SFUs, WebRTC SFUs. And one of the things we talked about, and I did this obviously with Rachel, who's maybe in this building, and Felipe and Kevin. So this is not definitely kind of my ideas. I'm kind of standing on the shoulders of giants. And one of the things we talked about in this kind of blog post is, you don't have to read it, this thing called, made up name NACK shield, which is like, oh, okay, like, what if we cached a lot of the packets that get sent for WebRTC in the SFU instead of sending it back to the publisher of a track, and would that improve the amount of packets that are lost? Could it be recovered faster? What if it's closer to the user? What would happen? And I was like, oh, this is kind of cool. Nobody talked about it. I never heard to talk about this kind of concept. I did hear some people architecting different, kind of networks that optimize for, packet loss and latency and stuff like that. But I never kind of heard about this thing. So I was like, okay, it would be kind of cool to talk about these things. But then after I published, a few days after I published this blog post, Philip, Fipo, messaged me and texted me and sent me this, saying like, that people have been doing this since 2016, and this is not something new. This is something standard, and maybe you're reinventing kind of the wheel, or this is not like as exciting as you think, which I thought was very exciting. And people were discussing, and they're like, oh, Jitsi does this, and other people do it. This is not, you're not reinventing everything. So I thought, oh, okay, this is interesting. Maybe that ruins my entire, topic of my talk. And I was very excited about this kind of until I received this. And kind of, this made me think, okay, like, maybe I can make this talk about NACKs and kind of like this packet recovery path. And people have seen this kind of, this style of diagram about WebRTC. But WebRTC, for those who might not know, in the flow of the media, there's packets that flow. They're UDP packets. There's it just comes to the browser, and then browser provides some sort of feedback over RTCP, and browser can detect, oh, okay, or the WebRTC client can detect, oh, this is the sequence of packets I'm receiving. There's 1, 2, 3, 4, 5, 6, 7. And then if 6 is missing, for example, it can say, oh, I was expecting 6, but I didn't receive 6. So here's some feedback. Maybe you can send me 6, and if I get it in time, all good. If I don't get it in time, not. But there's a mechanism that provides feedback to whomever is sending the packets. So I thought, okay, maybe what can we do with this data? Like, this data is important. We recover, we can recover packets. We can get data from this. Kind of, what can we do? This is, by the way, a representation of what I fed ChatGPT a description of what NACK is, and like a technical description, and then I said, oh, okay, tell me, show me a picture of how people would feel. And wanted to kind of share this because it's hilarious. So if you're making an SFU, so when we were designing Cloudflare Calls, has kind of a unique architecture than regular SFUs. If you're making SFU, for example, and if you have a global audience, you might have two different maybe SFUs, one in San Francisco here and one in Japan, and then these people talk to those places. Maybe they're separated by geo-IP, maybe they're separated by some other mechanism, but they're mapped in different ways. And a problem that people have is, sometimes these paths cross, and places that should be connecting to wherever they're close to connects to somewhere else. So one of the problems kind of Cloudflare Calls solves is that, and Cloudflare in general is in the kind of business of solving this, is Cloudflare has a lot of computers around the world, and there's a map of like where they are, and people always connect to the closest place around them using a technology called NACKs, which is that all the Cloudflare servers have the same IP address, and your ISP determines, okay, what is the closest place I can connect to, and kind of establishes a connection there. So Cloudflare Calls, SFU allows you to connect to the closest place and establish a peer connection, and then through that peer connection, you can tell Cloudflare, okay, I have a track there, how can I get this track from here to here? And you can kind of have different topologies formed through this. So a practical example of this is like, for example, if you want to get, a media packet from red to green, these people would make peer connections in between, and then you would have some sort of connection in between, and then there's another peer connection on the other side. And the closest place they would connect to, for example, if you're in New York City or if you're in San Francisco, you would make connections, and then the packet flow would go there. And then this scales the same way, where if somebody joins in Paris and you're trying to get a media stream track, for example, in WebRTC from here to here, there's a peer connection formed between each of them, and then Cloudflare takes care of the middle. This goes the same way, if there's another person who joins in San Francisco, it's just duplicated within San Francisco. And this is kind of the architecture Cloudflare Calls forms. And if you have another packet coming from here, it would be another tree structure going back. So why am I kind of describing these things? Again, another person who joins, and then maybe they connect to the same computer here, and maybe they don't connect to the same computer. Because there's, potentially there's many servers in one location. This makes it so that, and this is kind of what I find interesting, is there's 3 different areas that we can measure packet loss. Because normally, in an SFU, you would have the SFU to the client, and that's it. But here you can do, Cloudflare has, again, 350 whatever locations. So I feel like this is a good kind of max limit of how distributed you can get and how super close to users you can get, far beyond what you can achieve with public cloud providers. And what also, one thing that I have the luxury of is, okay, in Cloudflare we can do, we control network and we own these machines, so like we can have visibility into the network. So there's like this path, maybe the last mile of the packet, and then there's the middle, and then there's the first mile. So one thing that I wanted to share is, and I couldn't find any data, is I wanted to see what kind of packet loss are there in these steps, because I feel like Cloudflare is a good representation of, especially these paths are very optimized. So maybe this is a limit, or maybe I want to share some real data with the industry and see what people get. And this is very relevant to like Luke's work, because this kind of architecture adapts to MLQ, and like for example, if we were to build a media over quick CDN, it would work like this, and it would use the same infrastructure. And today you can use this with WebRTC, but protocol independent. So I was like, okay, First thing I went was first mile. This is kind of this side of things where people are sending packets up. And I said, okay, first mile, and I separated them by regions. And this is like percent packet loss. And packet loss is measured by the number of packets that were received eventually, and then divided by, number of NACKs we sent divided by number of packets received. And weird numbers, and I divide them by kind of region. So small text, but it says Africa, APAC, Europe, and then the top is Africa. The top is South America and Africa. And I was like, okay, like this is kind of interesting, but it doesn't really like tell a story. Kind of what does it look like in detail? So I was like, okay, I separated these things by different Cloudflare locations, and kind of doesn't matter where they are. But this happens to be, for example, Lima, Peru. And there's just crazy outliers here where maybe there's like a user here that is spamming us with NACKs, or there's some weird connectivity issue of one user that is kind of really skewing this chart. But most people happen to be kind of on the lower end. So in reality, when we zoom into the bottom area, and here, for example, you would see 30x, we're sending 30x NACKs. And by NACK, I mean sequence numbers in NACK. So like this packet was lost kind of detail. When you zoom in, the numbers we get is something like this. And this is all real organic data, by the way, that's using like Cloudflare calls. And so you get like 0.5%. I don't know if that's good or bad. I kind of want to know what other people see, but this is the kind of data we see, and there's like a huge area here where it's like very low. So there's not that many packets lost in the first mile when people are sending data. Last mile is much more interesting. Crazy numbers. So this is again regions, and this, when I say last mile, again I'm talking about this area where the packet is flowing from left to right, from red to green, and we count the NACKs that are sent by the user back to Cloudflare. So this also includes if your Wi-Fi is bad or whatever. You would still send a NACK and then we would repeat it. So this is not, last mile really means last mile, including, your Wi-Fi or cellular phone or whatever. And there's much more data here because a lot of people use Cloudflare calls today, in the past. This data is from last, whatever many hours there is, 3 hours, as measured this morning. But in the past like 6 weeks or whatever, Cloudflare calls have been out. A lot of people have been using this for broadcasting use cases. So there's a lot of like one-to-many type of thing. So there's much more data in the last mile than first mile. Crazy data. What is happening to Middle East here? What is happening? So TLDRs, I don't know, but these these things have crazy skewing numbers. So when we break it down by kind of location, log scale, by the way, actually turns out there's a lot of crazy kind of places where people are asking for retransmissions a lot. And then, middle, there's a band here where it's like maybe 1% or whatever. That's very crowded. And this is by location again, Cloudflare location. And then there's a lot of jumps up and down. So I thought that was kind of interesting. And then again, this is data that we see. I don't know what to tell, but it's like, there's 1% packet loss. Is that good? I don't know. But, this is what, including everyone's Wi-Fi and what people send, this is what we see. And then the third area, I should have duplicated these, is these middle bits that I am very open to, and I would like to, really obsess about this middle area, because this is area I have control over. This is like, I can't come and fix your Wi-Fi or whatever. But then here also, like, maybe your Wi-Fi is bad on the first mile. But the middle, I have control over and I can do something about it. And I'm sure there's a lot of creative things and other people have done. I've seen one or two talks about kind of building, networks that build crazy topologies that pass packets around and make it good. So the data for log scale, again, inter-data center packet transmission, retransmission, all over the place, some crazy numbers, again, but most of them are like maybe 0.5%, but very kind of long distance places have, and what are these numbers? I'll get to an example. Long distances have big kind of packet loss, especially long distances where we don't do anything special might have big packet loss, like something like Bogota to Belgium, or something like very long distance. Maybe it's not using the Cloudflare backbone. Maybe there's something wrong with that ISP in that location. There's so much data here that needs to be unpacked and maybe understood better. So what I did was I picked 2 locations, and one thing we do is we probe every Cloudflare location from every other Cloudflare location and record this data of, okay, how much packet loss success is there? Send something and does it ping back? So an example I found from the previous charts that is changing is Istanbul to Manila, Philippines. And this is IPv4, IPv6. And what's going on? Again, I don't know. But there's some sort of success rate has decreasing over here. And people who are maybe connected to Istanbul and there's somebody else in Manila, there's some packets we are losing and retransmitting inter Cloudflare, and maybe this is affecting the end user experience. So, and by the way, in the same time, the RTT doesn't change. So maybe the retransmission there is taking a lot of time. 400 milliseconds is a lot of time. And this is kind of driven by speed of light. The other thing I did that was kind of interesting and we collect is, since we own these physical machines, there are switches that connect to different providers that sell different transits, different fiber optic providers. So here in this route, there's actually 3 ways to get over IPv6 only between from here to here, and they're kind of decreasing. I don't know what's happening. Maybe there's something happening that's interesting. But one provider is much better here, while others are kind of following the same way. So maybe kind of one thing that could be done here is switch to using this and send more packets using this instead of these, right? There's a lot of kind of different optimizations that can be made. But I tried to collect kind of a lot of data that is kind of interesting to me. And again, this number of kind of every interface detail from every location to every other location is a lot of data. So I kind of I'm trying to figure out what's the best way to handle this, because we have, not every protocol has good kind of NACK style feedback mechanism. A lot of protocols like, I don't know, DNS or whatever, you can't just measure these things. But WebRTC actually provides a very, very good way of measuring feedback. And one thing I didn't say is that the way we measure the packet loss here is if we send packet loss here, if there's packet loss here, and then this doesn't have that packet loss, it backpropagates the NACK over here, and then we can measure that there was backpropagation happening. So these are some things that I measured, and again, this is RTT. And kind of there's interesting things I want to really spend time figuring out what's happening here. I've already found a bunch of different places where different ISPs weren't talking to other ISPs for random reasons, and the packets were going through a third ISP. Why is it doing that? There's no reason, but somebody misconfigured. I caught a few misconfigurations, And literally in the physical world, you just call up those people and say, hey, can you please do this thing? And then one of them doesn't reply, but the other one replies, and then they do something, and then they configure their router correctly. But kind of that is the journey I went through. This is kind of maybe it warrants a sequel presentation, but this is kind of where I am because we launched this product a few weeks ago, and this is the amount of organic data that I was able to collect. And hopefully other people have other data that I can share. That's it.